And welcome back. This is Chris here with another new tutorial session on manufacturing process. This is part 5, and today we'll be focusing on FEA analysis, the part where everyone is talking about simulation and so on, check for strength, stability, thickness, and everything like that. Yeah. So before I get started, as I've stated on the previous video, I'm rushing the recording, so my voice might be a bit echoey and whatnot because I'm not currently away from home. So please don't mind that, and hopefully get the information you need to be able to proceed for your classes or whatever you're trying to achieve, right? So we need to go towards simulation, right? So focus on simulation. You can see here is how we check for simulations, right? So you need to be able to enable simulations from this tab. You might not find it at first. You can go to Solidworks add-ins, or under the gear button here, there's a arrow at the side. Just right click that, just left click that, and then press on add-ins, and then click on Solidworks and press OK, and then in a few moments your Solidworks simulation will load up, right? And then you can have your simulation here. So as usual, as always, you only need one leg. You do not need all 5 because that increases processing power, and there's no need for that. And the cool thing about simulation is that it is able to calculate your parts as if it has 5 or more legs at the same time. It's like a circular pattern. It's able to calculate that without adding too much extra processing power, right? It's something called a cyclic symmetry. It's one of the very cool features that you'll be able to get onto later, right? But for now, let's not get ahead of ourselves. You can see we want to achieve these results, right? You want your MPa to be less than 14. So this is +1 here. +1 means move 1 decimal, right? It's to the power of 10. 10 to the power of 1. Yeah. So just move 1 decimal. If 0, it means it's 9. If it's 1, plus 0.1 here, it means it's 10, right? 10 MPa, right? This is not the most accurate because you have not done any local mesh refinement. Oops, sorry. But for this part, we'll be focusing only on the core mesh no mesh refinement, or the core parts lah. Yeah, core analysis, and to get you up to speed to be able to actually do the refinement yourself, the analysis yourself, right? So simulation, you see this new study, you click on new study, and then you want to use static. So general simulation, the rest you don't need to care about that. That is more towards other simulations, right? But for us, it's just a static simulation, and then you pop out with this part, right? So you want to check to our specifications needs, and you can see 110 kgs for 5 years. That's approximately 14 MPa. So this is all calculated using the SN curve we mentioned previously at the start of the series. During the introduction, you can watch back towards that. But basically what you're targeting, if you're following this requirement, it is lower than 14 MPa, right? Lower than 14 megapascals, and your kg is your weight would be 110. So the force that is going to be applied, so when you're sitting on here, right, you sit on down, the force is going to be applied not down, right, but the reaction force, right? Because you are sitting on there, so your entire body is going to be pushed on your your chair, right? But the force that is actually reacting towards this chair base is actually the reaction force, which is on your parts here, right? Because this is where your static is, right? Your force is going to be moved, it's going to be pushed up, right? It's going to fight against your weight, right? So what does that mean? That means that you have 5 chair base, right? 5 chair base. So chair legs, I mean. So 110 newtons, right? 10 kg, 110 kg is 110 newtons of force. We just use 10 kilograms, 10 newtons per kilogram in this case lah, because F equals ma, right? And you need to divide the force by 5, right? So each leg is going to handle 220 newtons of force, right? Not 1010, right? Okay, so you need to understand that, right? This is all very basic physics thing, right? If you don't understand, just watch a physics tutorial or something. All right, not part of this, but you just need to know 220 newtons for the end of your legs, which is going to be this part here, right? This part here is going to be where your force is going to be distributed. It's going to be pushed up, and your chair is going to bend upwards, right? It's going to flex upwards and displace, right? And then this part is going to be where your hydraulic press is, hydraulic press here, and then it's going to be an immovable object. So it's going to be a static object, because that is where your reaction force does not move, right? Because this is a perfect simulation, so we do not count things like twisting or anything else, right? So just focus on this, and before you run your study, you need to find out, you need to add your fixtures, right? So under fixture advisor, no, under external loads advisor, wait, where is it? Okay, first thing first, you need to go apply your material, ensure your material has been applied. In this case, your PP copolymer should be applied, good. Then you need to go to your fixtures, and then you want to add a fixed geometry, right? So your fixed geometry is here, so you can see your fixed geometry is where it's not gonna flex, right? Because your reaction force is applied up here, so this is gonna be a fixed geometry, fixed geometry here, right? And ensure that this is not, you can have like roller sliders, all of this, but just ignore that. We just need this to not move, right? This will be where everything starts, your pivot point basically, right? Then the next thing you want to go is under your fixtures is your external load. You right click it, and you will have force, right? Force, torque, everything. In this case, we're just focusing on one thing, that is going to be force, right? So force, you have force here. Then you can see, torque, force. You want to focus on force. You want to have SI is okay, per item or total. So 110 newtons per item or total, well, that is for you to decide, right? If it's per item, means each leg is 220. If you have 5 chair base, but in our case we only have 1, so we just use per item here, and put 220. So there's 220 newtons, F equals MA, right? And then you want to check your normal. Instead of normal, if you click on normal, right, normal is going to push towards one direction. So if this is put up here, right, it's going to push outwards, right? It's going to push here, it's going to push here, it's going to push here, right? But your chair doesn't move that way. Your chair goes up, right? It doesn't move towards the side. So you select a direction, right? You want to make it move up rather than push towards the side, because your force is not pushing towards anything. It's not moving, right? It's just moving, pushing upwards, right? Just handling a weight in this scenario at least, right? So your face here. So this is where your normal to is. So you want to click on the face below that, and then you want to click on the parts that's going to be there, and then you want to add normal to plane, right? So your force is going to be normal to plane, and you click on it and you can see it goes up, right? So face, click on the normal plane, and then parts that's going to be perpendicular towards your direction. And in this case, it's under here, normal to plane. You can check here along with plane. If along with plane you have a plane that's along there, you can use that as well, nothing wrong, right? But in our case, we just use a parallel to perpendicular to plane, right? So yeah, it's 220. Write that again. You can see the force 220, and now it's pointing upwards, which is the direction we need it to be. So bam, there we go. So right now, that's it, right, for your forces and everything. But you have forgotten one thing. Your chair base is actually not one leg, it's actually 5, right? So you need to ensure you have a cyclic symmetry. Where is cyclic symmetry again? Cyclic symmetry, applied graph region. I think it's under mesh, right? Under mesh, apply mesh control. So apply mesh control is where you add your local mesh refinement, which we'll get onto later, right? Where's my cyclic symmetry, to be honest? It seems I've lost it. That's not good. Shall manage your fixtures, make rigid, remove mass. Cyclic symmetry, where are you? Mass properties. Sure, the weight is still less than 1 kg for 5, yeah. Oh, where is my cyclic symmetry? That's not that's an issue, isn't it? Cyclic, I think it's under external load, right? Was it under fixtures? Definition, advanced, right? Use cyclic symmetry. It's here. So cyclic symmetry, to ensure you can see your part is actually it's not rendering the entire thing, but it's gonna render as if, right, process as if it's an entire circle thing, right? So you click on that, and you want to click on your face, right, which is your fixtures here, and you go for your size here. You want to click on here, and you want to click on your other part, right here. So your two side panels, and you want to click on the middle, which is your axis. You want to ensure that there's 5, or it can automatically do it for you, and you can see there's 5 legs now. So it's going to render with that, right? Render with that, right? So now you have this. You can just run your study. Everything should be fine. There should be no issue. This is your static 1. Run your study, and hopefully it won't take too long. Is that it? Is that it? Is everything all right? No restraints are denied. No restraint. Restraints. Forgot to add fixed geometry here. Yep, you still should not forget about your fixtures. Yeah, because I accidentally deleted this. So next time you just go here and just go to fixed geometry again, and then you just add it in, right? If you forget, you need 2 of this, right? Then now we can run the study again. Should be fine now. You can see the memory usage is quite a lot, so it's quite heavy on your computer, right? And you can see, so the Newton, yes. Oh, now it's Newton meter square. So you just need to right click here. This is not megapascal lah, right? This is Newton meter square, so you just need to right click here and edit chart options. Under chart options, you want to go to definitions, and then you want to click on megapascal here. Newton square, yeah, megapascal here, and then you get this, right? So you move 1 here. It's actually the same, exactly the same power as we did here. So for your first mesh refinement, you should get something low value, but it's not the actual accurate value, right? You know that this is not the accurate value, but this is the value that if this is already over your 40 megapascal, then you know something's wrong. And then one other thing to note, right, before I end this, right, for this session, you need to know that if you see like a lot of blue here at the front and then a lot of green at the back, right, it's not a good sign. The best way is when you have the entire thing green. You can see all of this are wasted. See, this -4, right? -4, right? So it's very, very small power, right? So it's like a very small power. So the more blue you have, the less distributed it is. You think of it as a spring, right? If it's something that's like a pasta or a very brittle, it's strong, but it snaps easily, right? But as a chair base that's constantly being used, you do not want it to have any micro fractures. So you want to ensure it has flexibility and it's able to distribute its weight well, right? That's why a lot of designs outside, they don't really achieve that, and you can see here there's still a lot of wasted, and you can remove that, but reduce the height of this thing. But if you follow this formula, then you'll know that I equals BH to the power of 3 divided by 12. That height is also quite important for your low and high area of moment of inertia, right? To achieve a high area of moment of inertia. So yeah, it's a balance between them. You can refine it more and more, but for me, usually the rule of thumb is the higher the better. But you can see there's a lot of wasted space here lah. But I think this is okay, right? And the other thing to note is check for your displacement. Click here to show displacement. You can see displacement mainly here, right? There's no displacement here, which is to be expected. So this part is flex a lot, and your displacement Later you can jot that down once you do the other simulation 2 and 3 for more refined version, right, which I'll teach you on the next video. But your displacement shouldn't change too much, right? Shouldn't, right? So there's your stress. So mark down your notes here. 10 megapascal. I've achieved it. I'm happy. Alright, thank you. See you. Bye bye.